Lesson 1 is finding average value for integrals. Okay, so basically, what do we do when you're working on a calculus problem and it asks you to find the average value of something? Okay, how we change things up. So, to introduce, the area of a region under a curve is greater than the area of an inscribed rectangle and less than the area of a circumscribed rectangle. Okay. The idea, if you remember when we first started drawing our rectangles in, sometimes we drew in left rectangles, sometimes we drew in right rectangles, but depending on whether the rectangle was under the curve or above the curve would depend on how accurate our answer was, right? We talked about sometimes our answer was going to be an underestimate, sometimes it was going to be an overestimate based on the situation. Well, that's what this is talking about there, that the area under a curve is greater than the area of an inscribed rectangle, so if the rectangle is totally under the curve, and less than the area of a circumscribed rectangle, which is when your rectangle is above the curve. The mean value theorem for integrals states that somewhere between the inscribed and circumscribed rectangles, there's a rectangle whose area is precisely equal to the area of the region under the curve. Okay, so mean value theorem for integrals states if f is continuous, so continuous curve on the closed interval a to b, then there exists, notice it says there exists a number c in the closed interval such that the integral from a to b of f of x dx is equal to f of c times b minus a. So the idea here being that the interval from a to b, where c is that point somewhere between a and b, where if we were to do this integral, because of the overage and the underage, I just made up a word there, I think. I don't even know what word I want to, what word would I put in place of that?
The yellow part.
But because here, this piece right here is overestimating, this piece right here is underestimating. The idea is that there is some point in between A and B that will equal that out. Okay, so if this is C, that of course makes this f of C, because it's the function with C put in. Now, with that in mind, let's put, it's been a hot minute, it's probably been since Unit 6 since we've really talked about integrals. What does the integral from a to b of f of x dx represent? An integral represents what?
The antiderivative.
Okay. Antiderivative, but in terms of a graphic, it is our area.
Under the curve.
Okay. Now, with that in mind, f of c times b minus a. Well, b minus a is going to be, we take b and subtract a. Think in terms of, if we're just thinking of this as a rectangle, yes, which is what it is, that is your width of the rectangle, and f of c is going to represent your height. So this is the idea that it's height times width. Okay? So again, just some, remembrance there, and we know height times width is area of a rectangle. Now, note, mean value theorem doesn't tell us how to find c. It just states that it just merely guarantees the existence of at least one number c in the interval. So it's one of what we call our existence theorems. Okay? It just says that there's some place here, maybe not necessarily right in the middle, where you can find that area. It's going to be equal to the actual area. Okay? So that's one piece of information we want to review, I guess, so to speak, and talk about a little bit. And we'll talk about mean value theorem a little bit in some of our homework or examples. The other piece today is average value, which I feel like is more the focus of this lesson. So the value of f of c given in the mean value theorem for integrals is called the average value of f on the interval A to B. And so, okay, if f is integrable, I can never say that word, integratable is what I want to say, but on the closed interval a to b, then the average value of f, okay, so when they ask for average value, it's the integral a to b of f of x dx, but notice what's out front. It's 1 over b minus a, okay? So that is the integral, the b 1 over b minus a is helping us to find the average. Sorry, I'm trying to avoid a coffee fit. So, when you're asked to find average value, okay, you're still going to be doing this integral, but out front we're going to be looking at the 1 over b minus a, okay? And I believe, if I recall, there's an example that will help us to explain that a little bit. Where was it? Yeah. When we talk about 1a and b, okay? I tend to write the average value like this, 1 over b minus a out in front of the integral. Notice it's also stated that you can write it like this, or you can put the b minus a underneath. It's the same thing, right? Okay, same thing. Notice here, if you think about it in this way, the integral from a to b of fx dx is your area, yes? Okay, b minus a represents the width, and f of c is going to represent the average height. Okay, so basically, if you relate it back here to mean value theorem, if you take f of c and solve for f of c, it's dividing over the b minus a. And so you're able to find that average height, f of c, based on some c that we don't know exactly where it is, but some c that exists. Okay, so that's your connection there between average value and mean value theorem. Okay? That's everything I have on this page. So let's turn the page and look at some different types of examples. I'm trying to glance at homework to see. Okay, yeah. So, number 1. Given f of x is 3x squared minus 2x, A, find the average value of f on the interval 1 to 4. So what am I going to do?
Find the average value of f.
Okay, average value, which means we just talked about average value, yes? It's going to be that 1 over b minus a times the integral from a to b of f of x dx, right? That's what we're going to set up. I heard some murmurings about what a and b are. A is 1, b is 4. So let's set it up. 1 over, I'm going to say 4 minus 1, but I go ahead and put the 3 if you want, times the integral from 1 to 4 of
3x squared minus 2x dx.
And then dx. Okay. We're going to do this one without our calculators. We're going to use our brains.
Oh,
1 over 3. Okay. Integral of 3x squared.
X cubed minus x plus 3 plus. Wait, no, we don't do plus 3.
Okay. Integral of 3x squared.
X cubed.
Add 1 to the power. Divide by the new power. X cubed. Right? Add 1 to the power, so it becomes 3. Divide by the new power, the 3's cancel. Probably because I'm gonna write the evaluation piece at the end. You could still have parentheses, it'd be fine. I mean, you know.
Sorry.
Nope, that's fine. Minus, what's the integral of 2x?
X squared.
X squared. Add 1 to the power, divide by a new power. And then I probably did bracket out of habit. See, honestly, I didn't even think about it. Because we're not going to say plus c.
You first say evaluated at.
Evaluated from 1 to 4. And you typically put either the evaluation line or use it on a bracket. Okay.
Can you have evaluation bar and a bracket?
You could. Okay. Now, do you guys remember anything about how to do this? It's been, I don't think we really did this at all in Unit 7 much, but.
It's just like b minus a. Well, it's like you put it in, but it's b first. A.
Yeah.
Isn't it like
Okay.
4
B minus
cubed
F.
minus
Yeah.
1 of 1 cubed?
Wait, 4 cubed minus
4 squared.
4 squared. So plug in the 4. And then it's going to be minus. And now I'm going to plug in my lower bound. So 1 cubed minus 1 squared. Does that sound at all familiar?
Mm-hmm.
I just figure we need to review this because I feel like it's been a long time since we've done this. So, okay, 1 cubed, let's see, or 1/3, I mean. 4 cubed,
It's 4 times 4.
What's 16 times
16
4?
times 16, 130.
You know?
16 times
No, no, no.
Out the calculator.
Without the calculator.
Okay, so here you go. Here's what you do when you don't know 4 cubed. 4 times 4 is
16.
16. 16 times 4. 4 times 6 is
24.
24. 4 plus
64.
the 2, 64. Oh my goodness, people. 64 minus 16.
48.
And then over here, minus, what about 1 cubed minus 1 squared?
0.
Because that's going to be 1 minus 1, yes? Okay, so now 64 minus 16. Well, since I have 64 written over here, 64 minus 16, we do this by hand if we have to, right?
Yeah.
If it's not in your brains, do it by hand. I'm going to borrow from the 6, it's a 5. Add 10 to the 4 becomes 14. 14 minus 6 is
48.
8. 5 minus 1 is 4. So I'm going to have 1/3 times 48.
60.
Then 48 divided by 3.
And 48 divided by 3. 3 goes into 4 once. 4 minus 3 is 1. 3 into 18.
Then 18 times 18.
Did you guys make stupid mistakes with that like this? Is that why she's going over this?
I don't know, maybe.
No,
Strong possibility.
no. This is just past. This is just past practice
I feel
of.
like after you do calculus, and
So you can be included in this too. You've made stupid mistakes, like like Kylie was reaching for a calculator. I was specifically wanting this one to be non-calculator, so I'm forcing us to. If you don't know this math and you don't have a Doug in your brain that's spouting off the numbers for you, you do this, right?
Yeah.
Okay, you do this, and you try not to make stupid mistakes, right?
But you still
So.
go slow.
And don't be afraid to write it down, right? This scratch work on the edges of your paper is perfectly fine.
No, she's still going to
Miss Sargent, will you judge me if I do like 2 divided by 8?
I'm going to judge you
Just kidding,
if
I
you
know.
don't write down anything and then you get the wrong answer when you could have easily, checked it out.
Honestly, that's what I did on the test. I guessed on a question.
I always have the scratch work of like random little things. Or it's always on my calculator.
Why?
I didn't guess on
I
any
don't want to work
questions.
it out. I had heard too much and I didn't feel like working.
You are such
Okay, B. Find the value or values of C guaranteed by the mean value theorem for integrals.
That's hard enough.
Okay, now, if we think back to this page, mean value theorem of integrals, right here, yes? That's the idea of that will find us some C value. Now, let's see. I guess before I go too far, if we look at what I'm basically going to write out here, basically you're looking at the area is equal to the height times the width, yes? And so the piece of information I have written on my notes is that the area under the curve is equal to the function value times the width of the interval. So like that's kind of what we are thinking here when we go to find this. So area under the curve is going to be equal to, I don't want to say that, do I? Yeah. Okay. The function value times the width of the interval. Now, how do we find the area under the curve? That's doing the integral, yes. The integral, what was it? From 1 to 4 of 3x squared minus 2x dx. Now, and we'll come back and deal with that here in a moment. Okay. The function value, what we're talking about when we talk about function value, if you go back to the previous page, that's just the idea of f of c. Okay? Because again, we just know something's guaranteed. Okay, we have to work to find it. Width of the interval, what's the width of my interval? 1 to 4, so 4 minus 1 or 3, right? I went ahead and put 4 minus 1. Now, integral. What's the value, I'm not going to redo the math, of the integral from 1 to 4 of 3x squared minus 2x?
48.
Are you guys good? It's 48, it's not 16, yes?
Yes.
Because it was going to be a third of 48, so this was 48. Okay, so we basically have the idea that 48 is equal to f of c times 3, yes? So what's that tell you f of c is?
16.
16. And I'm running out of room here. I must have written too big or something. Okay, I'll have to move over here. Now, f of c has to equal 16. What is f of c?
Isn't that like 3x squared minus 2x?
Except plug in c. So if f of x is 3x squared minus 2x, how could I write f of c?
3c squared minus 2c.
Can't write a 2 though. So we are at the statement that 3c squared minus 2c equals 16, yes?
Yes.
How do we solve for c? Because our job is to find the value or values of c.
Subtract 16, make equal 0.
Okay. Subtract 16. So now I have 3 squared minus 2c. Knew I shouldn't have done that. Minus 16 equals 0. And okay, 3c squared minus 2c equals 16.
PAC. 3 times negative 16 is negative 48. Multiply, or you need two things, multiply to equal that, add to 3 negative 2. So positive 6, negative 3. So
You guys are gonna like Doug's way better than my way,
3c
because I don't have any work on my paper. On my paper, I have it set up and I just did more guess and check. Now, and here's the deal, okay? So Doug's talking about product of AC, which is by all means what you do to work it out, yes?
Yes.
Okay? 3c squared. What does 3c squared have to break up to in this scenario?
3 and 1.
It's 3 and 1, so 3c and 1c. We don't have any other options, do we? Now, the end of each parenthesis, okay, 16. we have a few options there, don't we? That's the thing that makes this one difficult, is because it could be 1 and 16, 2 and 8, and 4 and 4. So that's, and again, you're trying them out. Remember, you have to get that sum of -2 in the middle. Okay? It's like, I'm going to ixnay the 1 and 16 probably, just because that doesn't seem like it's going to work. So, like, if I tried 2 and 8, well, no. 3 times 8, your outsides are 24. Are you following me here? Your insides, 2 times C is 2C. Is that going to give me a difference of 2C? No. Okay, so we could try 4 and 4. Now I'm at 12C and 4C. 12C and 4C does not subtract to give me 2C. 2 and 8 can also be flip-flopped to be 8 and 2. Yes. So now look at your outsides. 3C times 2 is 6C. Insides I have 8C. And if you really hate what I'm doing, then productive AC, right? I just, as calculus kids, I like to try and get you to think this way. Okay? You have to make your signs. We need 8 and 2 to multiply to be negative. And we need this sum to be -2C.
-8.
So it has to be -8C and then +6C. +2, making it +6C.
Then you say
You lost me. I'm fine now, though.
Okay. And that's
For a second, when you said +6, I was like, oh,
no. +6C, which happens when you make the 2 +2.
which I understand now.
Okay.
So C is -2 and
Kind of.
Oh. You can't read.
Well, yeah. That's the 2
Okay.
that you get from
Yeah.
subtracting. Because -2 is not between.
Is that our final
1 and
answer then?
-4. No.
Kind of.
Or -1 and 4.
What interval was this problem on?
1 to 4.
-1 and 4. Wait, why is it a -1?
So then there's extraneous solutions. C cannot.
1
so
minus-
C, the 2 doesn't matter. It's -2.
Is 8/3 in between 1 and 4?
Yep.
What is that? 2 and 2/3? Yeah. 2 and 2/3 would be between 1 and 4. So, and that's just, must be in the interval.
So then, what was the point of the rest? About FFC.
I don't understand your question.
Like, why do we have that there? Why did we need that?
Like this setup here leading
Yeah.
into it, because you're looking at it relates up here. Is that what you're looking at?
Yeah.
So officially, because it's saying mean value of theorem for integrals, and mean value theorem is this statement right here.
Oh,
So I kind of started over a little extra when I didn't have to, right?
okay.
But trying to set it up as
It's there to get your mind to.
there.
So you could have just been like, okay, what's FFC? Okay.
I mean, yeah. Looking back on it, yes. Had I done that at the time, it wouldn't have flown well. How's that for an answer? Looking back on it, I get yes, but I couldn't do that at the time.
Next.
Oh my god. Moving on.
Moving on.
I read it, and it kind of makes me excited because I feel like it's what we have been doing.
Okay, well,
So I got excited.
I thought you were going to say you got excited because you saw this
That too.
Oh.
and that.
Later.
Okay. There was a reason I wanted to focus on the other one without the calculator, because I knew we would include them here. So, and we just really need to review those integration skills and how we evaluate, and
They were a little aggressive.
we integrated some, but we never evaluated. We just had the plus C's last unit, right? Okay, so In 2000, the world's population was 6.1 billion, and the relative rate of growth was 1.4% per year. This can be modeled by the function n of t equals 6.1 e to the 0.014t, which means that entire first sentence was irrelevant because they just gave us the equation, didn't they?
Yep.
Where n is people in billions, and t is the number of years since 2000. Assuming this model remains true until 2050, find the average population of the world between the years 2010 and 2020, and what are the units?
So T equals 10.
Mhm.
And 20.
Still taking last.
So what are we doing here?
Integral of t to, or 10 to 20, 6.1 e to the 0.014t.
Okay. Average population, yes. Now, what were the bounds? You said 10 and 20. Why 10 and 20?
Because that's 2010 minus 2010.
The years.
T is the number of years since 2000. So that means 2010 is going to be represented as
T equals 10.
T equals 10, and this is 20. Okay. And then so the interval 10 to 20, 6.1 e to the 0.014t. Now, I don't think anyone said the piece we're missing.
Oh.
No?
No, the piece up front. Oh, average.
Bedrock.
Well, because it says average,
1 over. Because that's what I say.
I'm going to say 1 over 20 minus 10.
Yeah.
I get it, you know, just to be official. So if someone looks back and they'll say, why 1 over 10? Did they just grab the 2010? No, we subtracted it officially, but okay. And now what?
If you're good.
Mhm. Yeah, it's a calculator problem. Hello? I'm not doing that by hand.
I don't know why I thought we were integrating. Well, we are.
Yeah, you can plug that into the.
Yeah.
We have
Where's the integral button? Oh, number 9.
supposed to.
I found it.
You put that equal sign. It's not.
I'm not wasting my time doing that one by hand. I'm on the calculator portion of this test.
We were all just staring at you like, we're
I know, I'm like waiting for you guys to grab the calculators and like no one's, I'm like,
I was over
No.
here trying to figure it out.
No.
Need to go by hand.
and we could do that. I would do a U substitution for the exponent. That 6.1 is a constant, it can go out front.
Hooray.
So you what? 6.1 over 10 then?
6.1 over the 0.014. Oh, out front, yeah.
I forgot.
How do you?
Yeah, sorry, I was on a different part.
Huh?
Math, no.
Oh. Look at you, smart. Yeah.
There we go.
It's in the Alpha F2 menu. Number 4 also.
But it went really quiet. I don't like it.
7.5315. It's fine. My phone vibrates for no reason.
I thought that was like a whole bunch of phones going off at the same time for some reason.
No, my phone
Somebody
vibrates for
group
no
snap.
reason. I swear to God.
I forgot the 1/10, so now we get
7.5.
7.531.
Same.
You're here vibrate.
How did you get 9,000?
Did mine just vibrate?
Yes, it's just random.
That's weird.
I think I know. I think the person that fixed my phone screen probably messed up something.
Oh, yeah.
That's what they did in mine too.
But it wasn't doing it for the
What'd
past
you
2
guys
months.
get?
now, so-
7.531.
I got it. What did you do?
5. Honey bunches.
I got 9. Go home.
Okay, why'd you put
Nobody
time?
My mom sent me like 3 TikToks. and I can't
Dude.
watch them.
Why is your stuff there? I don't like it.
Doug, I would have done something like that. I'm doing it by hand. Because then,
Take out the
so we have the 1/10 out front, right? You have the 6.1 out front. And then e to some power. Well, there is e to u. And then the dt would be
You have it to answer.
du. And so you'd also have to have the 0.014 out front in the denominator,
I didn't see that.
if that makes sense.
Okay.
So,
Erased all the work.
and then you would just sub this back in, and I mean,
I could.
you still gonna have to use a calculator to get an answer. That's the thing. You just do all that work by hand. You still have to use a calculator. So, okay, we got an answer. Yes.
7.532.
So they wouldn't give us anything like that on AP and expect us to do it by hand.
I mean, they might. You never know.
It's
No, you would leave it in terms of e then.
okay.
You would not be expected to do e to some power by hand.
What is like the number e? Like what is e?
Like
2.718.
Oh.
That's what I remember it as, but okay. So I had written in my notes 7.53158. Nellie, I assume your issue got figured out, whatever it
She was
was.
multiplying it by an answer that she didn't know.
Oh, okay. Fair enough. Okay. Now, the other question, that is our average population. What are the units? In other words, put this answer in words.
Billions? No. I don't know.
No, wait, what was the question?
Average population. Population is in billions. I think
This is
I'm
the
right. I think it
average
is billions.
population after 10 years.
Average population between 2010 and 2020 is approximately what?
7.532 billion.
People? Yep. My answer key,
Sounds right.
I have written in mine, average population of the world is approximately 7.532 billion people between 2010 and 2020. I mean, those are the key, we're talking about units and explaining this, so. Okay. Average population of world is 7.532 billion. Definitely gotta get the billion in there, right? People between 2010 and 2020.
And COVID-19 knocked out that 0.532 billion.
Okay, C, we've got to get moving. I don't know if we're going to get that whole last page done or not today, but we got to get moving. C, suppose C of T represents the daily cost for air conditioning your house in dollars per day, where T is the time in days and T equals 0 corresponds to July 1st, 2017. Explain what the following expressions represent in real world terms, including the units. Okay, so you're going to have to go back and dissect that because I read quick. I need, what does this represent in words? The integral from 0 to 90 of C of T dt.
So 90 days after July 1st.
Okay.
How much it costs after.
Daily cost of air conditioning your house.
Okay, so C of T represents the daily cost for air conditioning your house in dollars per day. T equals 0 is July 1st, 2017. So this is indeed day 0 being that July 1st, 2017 to 90 days later, right? And then if this is 0 to 90 days, then altogether this is going to represent the total cost, right? So I have mine written as total cost to cool your home for July 2017 to another month in 2017. What would be 90 days later?
I said October 1st, but give or take, maybe
From
September
July?
30th.
Yeah, exactly. So you have July as a month, June or August as a month, and September as a month. So you're looking at the end of September, right? Beginning of October.
September 28th.
So I haven't done the math. I just have, and this is probably what she had, total cost to cool your home for July 2017 to September 2017. Because, you know. Now, could you just say 90 days, the 90 days after July 1st, 2017? Yes, that would be a relevant explanation too. So, total cost to cool your house for July 2017 to September. The big thing is you're mentioning that it's cost, right? You're mentioning total cost, and you're mentioning that basically you're getting the idea of 90 days. And by saying September, you're indicating you understand it's 90 days. Lots of different ways you could write that. Okay, B.
Average cost to cool your home.
Okay. So now, basically because we threw this out here, right? Now we see it's the average value function. So average cost to cool your house, I have in dollars per day. And this time I wrote for 90 days from July 1st, 2017. Okay. So key point. You've got to mention the word average. Average cost to cool your home in dollars per day. Ouch.
I love that.
For 90 days from July 1st, 2017. Why does that one have a calculator symbol by it?
I don't know.
I feel like she just added it.
I think she just tried to get her hopes up.
I'm gonna siphon it out.
I'm just all of a sudden I'm like, we didn't. It doesn't say find them. You can't find them because we don't have an expression for C of T. So, whatever.
Budget.
Okay, Supersonic Man. On October 14th, 1947, Chuck Yeager flew his X-1 rocket plane at an altitude of 12.8 kilometers. He was clocked at 299.5 meters per second, which is about 669 and 962 thousandths miles per hour. At different altitudes, sound travels at different speeds. We can model this variation for speed of sound with a piecewise defined function given below. Now, she referenced her data here. Data found at this website, if that even still exists, but you know. So, A, integrate the function S of t over the interval 0 to 80 for the 5 subintervals.
I just didn't know.
So, A, integrate the function S of t. Notice it says for 5 subintervals. How many integrals am I doing? 5. Because it's a piecewise function. So what's the first one we're going to do?
Negative 4t plus 340.
We're going to integrate negative 4t plus 341
dt.
dt from what to what?
0 to 11.5.
0 to 11.5. Didn't I write t or did I not write t? Okay, I just said d. So you're going to put that in your calculator and you're going to get an answer. Let's go through all these real quick and then we can divvy the work up.
1.5 to 22.
Next one is going to be the integral from 11.5 to 22 of
0.75t. Wait, no, 295.
295 dt. The third one. Yeah, see, this is never going to all fit on my paper. It fit perfectly fine.
22 to 32.
Okay. Third one, 22 to 32 of 0.75 t plus 278.5. And then don't forget dt. The fourth one. Everyone follows how we're setting these up now, right?
Yeah.
32 to 50 of 1.5t plus 254.5 dt. And 50 to 80, negative 1.5t plus 404.5 0.5 dt. I know, I'm just... Okay. Pick one and do that. Don't everyone pick the first one. Let's get all of our answers in one fell swoop. In other words, not everyone needs to do everyone, right?
I will do the fourth. I did the first one, and I got
What's the first one?
3,657.
And did these work out exactly? Because I have phone number answers.
Did. I don't know.
Okay, they probably do then. Okay, first one is 3,657.
Who had the second one?
I have 51,883.125.
I disagree.
Well, that's what 1,097. What did I do?
There we go. Did you put a T in here when there's no T? It's just 295?
Oh, I put XDX.
Yeah, there's no X.
That's fine.
So
Never mind.
I'll take Natalie's answer.
Please do.
3,097.5.
How would you put that one in your calculator and then if it's just 295?
You just type in 295, and then you fill in the X for DX. I was guessing Hannah did 295X.
That's what I did.
Oh, okay, I got the
It's because I thought you had to.
Yeah, feel free to try any of these you want as we have time, but... Okay, what's the third one?
Nobody wants the third one.
I'll do it.
I did the last one.
I did the fourth.
Okay, what's the last one?
9210.
9,210. Someone had the fourth one. Sophie, what's the fourth one?
8,288.
Say what?
Did I do that wrong?
I don't know. It's not what I have written down.
8,000.
I don't have 8,000 down.
Jesus Christ.
Well,
My answer is a 5,000. And my answer on the third one is 2,000 something.
hold on. I put in the wrong number. Oh, shoot.
This is why I have the answer key up here, and I'm not just going based on what you guys tell me.
I got number 4.
Okay,
You got it?
she's fixing
You're
it.
almost there.
So do I need to put an X for
5,688.
Yes.
That answer I'll take.
Well, I got the 8 part.
Oh, what? Yeah.
I don't feel like I should.
Yes.
What?
I don't feel like Number 3.
Number 3?
Yes.
You would type in 0.75x plus 278.5, and then with your D piece, you fill in the X for DX.
So I do put an X. That's fine.
You put an X right here next to 0.75.
Okay. I messed with ones that I don't know.
Okay, did anyone ever get the middle one?
I did.
What'd-
2,987.5.
There we go. Okay, those are the correct answers according to my notes. Whether you got any of them, none of them, all of them correct, whatever. Okay, that's part A.
Easy question.
Those were the easy questions, right? Okay, part B. Apply the mean value theorem for integrals to find the average speed of sound.
On all of them?
Do you add them and divide by 5?
Not by 5.
By 80.
By 80. Think of it, I'm going to put mine over here because I don't have room. In my notes, it's down here, but I am out of room here. So think of it is we're doing it as average value type because it's average speed. So it's going to be 1 over, when you subtract, it was 0 to 80. So 1 over 80 minus 0. And if I generalize, it's the integral of s of t dt. Right? And that should say, from 0 to 80. Now, we've already done all those pieces, yes?
Yes.
Okay, if you remember your integral rules, basically the first one plus the second plus the third plus the fourth plus the fifth is going to be equal to the entire integral from 0 to 80. So you're doing 1 over 80 times 3,657 plus 3,097.5. plus 2,987.5 plus 5,688 plus 9,210. That's the math you're doing on the calculator. And if you'd done this all on your own, you would have all those answers in your calculator. You could go grab them too. So add them all up and then divide by 80.
Did you get that?
Because you put the integral.
Oh.
Is that meters per second?
Oh, okay.
Okay. Sorry, I'm quickly running out of time. So, yeah, we'd already done the integral. So we're just adding those values up, dividing by 80. Adding the values up, I get 24,640. Dividing by 80, I get 308. Now, 308 what? If you go back and look at what we were talking about, we were at meters per second. What did the question, did the question ask? No, it just says average speed of sound. Because in my answer key then, I have it written in as being approximately 688.976 miles per hour. I don't see anywhere where it asks for miles per hour though, does it?
No, it uses it.
Just the beginning.
Okay,
Just because we're American and we use miles per hour.
exactly.
Yes.
Now, there is a part C,
No.
which is what I was trying to get to.
Homograph.
Draw the average value S of C on the graph below. What is our average value?
308 meters per second.
So where is our 308?
Like a little
Right
under
before
the
the 10.
310.
Okay. Now, the idea is that is the spot. That is like your F of C, if you will. Okay. That's like your F of C where the amount below and above should be equaling out. Okay. Okay.
Awesome.
We made it barely.
That was impressive.
I really want to see it.
Oh no.
Okay.
I know, me too.
Your homework. Due 8-1 for tomorrow. I know, weird thought. We're doing it on the first day of notes. But I know you guys would be annoyed about it because you're in your habit of, oh, she's teaching first day of notes today. We won't have homework due tomorrow.
A little bit.
Sorry.
Jump scared.
I think it's charging